Okay, we're back. Hello again, YouTube. So, what is the problem that I have with this uLink implementation? Um, I have two problems with it. Firstly, is the send rate. As I mentioned before, this implementation requires the client to send every frame, every update. So that means if the client run the game at 60 times per second, 60 frame per second, it would send the data to the server at 60 times per second, and I think that is a big waste of resources. And imagine someone with a monster rig that run the game at 200 frames per second. That just would just destroy the network on the server. And I want to try to keep the network load on the server as low as possible, since I'm an indie developer. I don't have all the money to maintain a big ass server. Anyway, yeah, that's one of the problem. I want to minimize the network load from the client and the server. And the second problem is that this script is not modular. It is tightly linked to the character controller. It requires the character controller to send in the information, the movement information, such as velocity and position. And that means if you want to try out a new character controller script, you cannot just plug it in and expect it to work right away. You have to fiddle around with the script and then link it into the this uLink platformer. And I think that is not ideal for the development. I like to be able to just plug it in and then make it play properly right away. So yeah, that's the two problem I have, and that's why I decided to write my own script. Okay, so let's jump right into my implementation of the character synchronization. My implementation here is for the most part is the same as uLink's sample code, but I need to do some modification on the character synchronization. I mean the send rate, how the data is sent from the client to the server, because as I said, sending every frame like that is not ideal. So how did I change it? First of all, I want this script to be independent from the character movement script, so that I can just plug it into the character object, and it will just synchronize the position right away without having to get the input from the other script. So the idea is I simply this script simply take the position of the character every 100 millisecond or some other rate that I can set it to. So every 100 millisecond here, it will sample the position. It will just take the current position at that time and then send it to the server. So that so effectively we are ignoring whatever happened in between here. And since it is just only 100 milliseconds, which is a very short time, it's 1/10 of a second, so we expect that the whatever happened in between here is negligible. So we simply just take that, and then we take the position within 100 milliseconds here as the reference, or what we say, the key frame, and then we just send that to the server in order to reduce the network load. And also, when we do it like this, we don't have to worry about some client running at much faster frame rate, and then we'll put more load on the server's network, because we are sure that everyone will only send at 100 millisecond or 10 times a second, so that the server knows for each user it can expect how much load it has to give to that user. So yeah, that's the idea. So I simply have the script to be invoked every time, every 100 millisecond here, and then we just take the position at that time and then send it to the server. Here, the data send, instead of sending velocity like before, we don't have to send that. We only send the new position. So what do the server do with that information? So similar to uLink script, we first calculate the delta time using the message info's network time, and then we subtract that from the previous time stamped from the previous message, and that will give us the delta time, and then we can calculate the velocity from that, because we have the new position and we have the old position, so we can just calculate. We can just take the difference between the new position and the old position, and then subtract and then divide that by the delta time, and we get the velocity from this point to this point. So when we get the velocity, we do similar the same thing. I think we just verify velocity to see that it is within the maximum limit, and then we move the character similarly, and then we do the same thing. We verify the new position for the server. Do the character controller dot move from this position to this position using that velocity and delta time, and then we check if the position at this time is the same as what the client say. We can expect that it can be different, because when we use character dot move here, it also calculate based on it also deal with physics. So maybe there are some different friction. For example, there is a slope. For example, the terrain has a slope like this, and then within that 100 millisecond, the client move up here and then down there, and then this is 100 millisecond. So in this case, the server will only take this position at the end and this position at the previously, and then try to move directly here. So in that case, we might see some difference when it uses a character.move and try to go straight here. And yeah, I'm pretty sure there will be some difference in that case, because the client actually move here, and then down back. So yeah, we can expect some difference here, but the thing is, because it is a very short time frame, 100 millisecond here is only 1/10 of a second, so we can expect that the difference is quite small, and it wouldn't be much of a problem. So yeah, that's my implementation, and we will jump into the script right away. So how did I do that? Here we go. The script is called character sync. Let me just show you. Yeah, we just put it into all the three prefab here: the creator, the owner, and the proxy. So inside the there we go, the character sync. So what does the character sync do? Like I said, first this is where it starts. So on start, I initialize the variable here and get reference to some component that I need. And here is the important part. We do invoke repeating. We can use other method. You can do it every update and then check the data time. But I think invoke repeating is more accurate, because Unity will just check on it and then make sure that the time is correct all the time. So I can just use invoke repeating and then put the send rate there, which is 0.1 second, I think. yeah, I define the same rate here as 0.1 second, and if I want to change it to something else, I can just change it here. So yeah, that would make do sync here method will be invoked every 100 millisecond, and the do sync doesn't do much. It just um, it store the character movement information, and that include the timestamp and the delta time and the velocity. And we calculate the velocity the same way as I mentioned here, the same way as what the server do. So the client, the server do the same calculation with the velocity. We take the previous position, I mean the current position, subtract the previous position, and divide that by the delta time. And this is how we calculate the delta time. We just take the current time and subtract it with the previous time. All right, that will give us the velocity, and we just store that in as a previous state. And this is for correction, as I mentioned before. Here, when we, if in case the server disapprove this movement over here, we need to be able to calculate again the movement that follows. So that's why we have to store all of these movement. So yeah, I calculate the velocity, the delta time, and then I put it inside the movement object here, movement class. Here we go. We simply have delta timestamp, delta time, and velocity. That's all. So we store that inside an array. Owner move here is an array. Here it's just a list of array, a list of move objects. So we add that into the list, and then wait for the server confirmation, and then we send unreliable RPC to the server, and in there we have information such as position and also the rotation. Yeah, so yeah, that's it for the client. We just send the new position every 100 milliseconds to the server. Next, what does the server do? First, the server will check if the new information or the new data that was sent here have the timestamp that is newer than the previous state, because sometimes network is kind of complicated. Sometimes the data that was sent before arrive after, so in that case we want to ignore those data. So yeah, we have to make sure that this new message is actually a new message, and then we check if the this is the first time the message arrived. So at the beginning I set the timestamp to be 0 because we haven't got any data from the client yet on the server side, so I set it to 0. So I just check if this timestamp is 0. I will just copy, I will just store that timestamp and then return, don't do anything, and wait for the next one so that we can calculate the delta time correctly. Yeah, that's just a little preparation here. So, and then we get into the main stuff. Here we calculate the delta time similarly as the client, and then calculate the velocity, and then we do the we do a verification on the maximum speed. So if this velocity is is larger, this one in case it's larger than the maximum speed, we want to scale it down to within the maximum speed. But if it is within the allowed speed, then there's no problem. And then we just move the character, and also we set the rotation. Yeah, rotation we don't really need to do any we don't really need to do any verification. I mean, we can the character, the client can turn to whichever direction they want. We don't really care. But maybe if you in your implementation, in your game, maybe you want to check that, then it's fine. You can just do a verification code somewhere here. Anyway, yeah, when that is done, we just store the new position, rotation, and the timestamp into previous state in the server side, and then this is where we check the position, the verification of the position. We just take the new position on the server side and then compare it to the position that the client sent. That will give us the difference, and then we check if the difference is within the limit or not. So if it is within the limit, we will we send the good owner post. That means we approve of the position. If the difference is larger than the allowed limit, then we send an adjust owner position, and also in there we send the position back to the client. That is all. And here I send the RPC to the proxies, and we will talk about this afterward, but I want to go to how the adjust owner and good owner position first. So here below here, this is the two function. So good owner post, this one because the server, it only send here the server mode if it's sent to the owner, so the proxy doesn't get this RPC. The RPC here only go back to the owner, so we can be sure about that. So here we are sure that this function is run only on the client, and that client has to be the owner. So yeah, and for the good owner position, we have the message info here that have the timestamp. So we just take that timestamp, and then we find that timestamp inside our inside the move that we stored before. As I said before, we store every move, every frame, or at least not in this case. In this case, because we don't store every frame, but we store every send rate. So but in there we also have the timestamp. So we find that time, the object that have that time, and then we mark that as good, and then delete it from the list, because we know that for this position is correct. So we just delete it from that index. And here is when the position is wrong. When the position is wrong, we mark that the object that has that timestamp as good, but we also have to we mark it as good. Here it doesn't really mark anything. It just means it remove that object out of the array, because we don't need it anymore. And so here we just move the position, transform dot position here to the position that the server sent, and then we do a for each loop for all the move inside the list. So and then we use character.move. So we move the player again, because we just sent them back to the position, and that position can be, like I said, because of the latency here, the message that was sent by the server can be way over here, and then we want to and then because we just move the character back to this position here that the server sent here, and then so we want to redo all the action that follows after that. That's why we do a for each loop for all the move that is inside the list, and then we do the character.move on all of them again. Okay, I'm going to cut the video here. So far we've taken care of the synchronization between the client and the server, but we haven't talked about the proxy yet, and I will do that in the next video. Thank you very much for watching, and I will see you in the next part. Bye.